Hello, today we're going to be looking at lesson 7, 6, 15. And again, we're going to be looking at how to solve inequalities. So the very first question is saying, here's an inequality, negative x is greater than or equal to negative 4. Predict what you think the solutions on the number line will look like. So this is just a chance for you to make a prediction. What do you think the solutions for x, so that means the numbers we put in for x, what will they look like if we were to plot them on a number line? So go ahead, put in your prediction, hit submit, and let's move on to the next one. For this one, they're asking you to actually select all these values that do make this true. Okay, so for this, you might consider writing in each number on in for x. So this is saying negative x. So for the first one, negative, and then we put a 3 in, is greater than or equal to negative 4. Is that true or not? So negative 3, and again, I'm just going to use this. I'm going to put a number line. I'm going to use a vertical just for now to help us remember how we know if a number is greater than or less than, especially when we're looking at negatives, right? So here we know if we go up the number line like this, the higher number's on the top, right? So this might be, whoops, 5, 4, 3, 2, and 1, right? So 5 is higher than 1 or 0. And then when we go to the negatives, it's actually the opposite. So here we have negative 1, negative 2, negative 3, negative 4, negative 5. Well, even though 5 itself is a bigger number than, let's say, 1, if it's negative, the negative 5 is actually lower than negative 1. So it is true that negative 3 is greater than or equal to negative 4. It's actually a bigger number than the negative 4. So um, this is actually true. And now we're going to put negative 3 in for x. So what that's going to look like is negative, right? Because it's negative x. So we do negative, and then I'm going to put a parenthesis here for negative 3, because we do have to include the negative that's here, right? And then it's greater than or equal to negative 4. So for this, we have to look at this and think of it this way, right? Or here's one way to think of it. This is saying what's the negative of negative 3? And whenever we're talking about like a negative number, it really means opposite, okay? So like for instance, let me finish writing this in. What that means is we are looking for the opposite of negative 3. Well, the opposite of negative 3 is actually a positive 3. That's what this means. So is positive 3 greater than or equal to negative 4? Yes. A positive is always going to be greater than a negative, right? No matter what the positive is. So the negative 3 for x actually works as well. Okay, so now let's look at this. We're going to do the same thing, but now it's positive 4. So let's look up here. I'm just going to erase the 3 from before. And we know that we're looking at 4 for x. So it says negative 4. We're using positive 4 for x. Is negative 4 greater than or equal to negative 4? Well, negative 4 is equal to negative 4. So that does work. So let's check that. And then we do the same thing for the next one, except for this is no longer negative 3. We're putting in a negative 4 for x, right? So wherever the x was, we put in a negative 4. So we're looking at negative 4. So the opposite of negative 4 is actually positive 4. And is positive 4 greater than or equal to negative 4? Yes, it is. So that works as well. Now, the next ones are interesting because they're very close to the ones we just did, but not quite. So let's look at this one. So we're going to put in 4, and that would be tenths, hundredths, thousandths. So this is 4 and 1,000th for x. So it would be negative 4.001 is greater than or equal to negative 4, right? So let's consider that on the number line, right? So negative 4 is our target number. It's right here, right? So if this is negative 4, this number, 4.001, is actually closer to 5, right, than it is negative 5, than it is to negative 3, right? So what I'm trying to say here is when we're looking at this on a number line, it's actually between negative 4 and negative 5, not between negative 4 and negative 3. So that number has to be a little bit less than negative 4. So is it true that negative 4.001 is greater than or equal to negative 4? No, that's not true. It's actually a little, actually 1,000th less than negative 4. But let's check this one out. If we put this negative 4 and 1,000th in, we know that that's going to be the opposite of negative 4 and 1,000th, right? And we know the opposite of a negative is a positive, so it actually ends up being 4.001 is greater than or equal to negative 4. And is that true? Yes, because this is a positive number. This is a negative number. Any positive number will always be bigger than a negative. So that's our choices there for that first warm up. So now let's go ahead and look at that graph. Kind of using, it says graph the solutions to the inequality on the number line to the left. So if we were going to graph this, what we know is our target here is negative 4, right? So we kind of have to add this on because there aren't any, well, negatives or anything like that. So let's see here. Okay, I'm going to see. Let's just make this 0. All right. Take that back. Whoops. All right, let's make this 0. So we know it's negative 1, negative 2, negative 3. And here's what I'm calling our target number because it's the thing in the inequality, right? And then this is negative 5. And then these, of course, go opposite 1, 2, 3, 4, and 5. Okay, so we know that the answer is greater than or equal to, which means it's going to include whatever number that we're putting on here, right? So let's go back to our other page and let's remember that negative 4 is a solution. Negative 4.001 is a solution, which is interesting. So when we start putting our answers here, we know that any answer to this, well, first of all, any negative answer has to be part of this, right? It's part of the solution. We also know that when we did, the only one that wasn't was positive 4.001. All right. Let's even think about 5. Let's put in positive 5. If we put a 5 in here, it would say negative 5 is greater than or equal to negative 4. And that's not true because remember, negative 5 is actually lower on the number line than negative 4. So when we look at the solutions here, we actually end up knowing that if the number is 4 is equal to 4 or less, it's gonna be the right answer. It's gonna make this true. So we actually know that x has to be less than or equal to positive 4 in order to make this true. Okay? Which might be a little bit tricky because of this negative guy. So let's start investigating some problems that look at this, okay? So it says, let's investigate the inequality x minus 3 is greater than negative 2. complete the table, and then it's asking which values make it true, which ones make it, is it true that x minus 3 is greater than negative 2? And which ones make it for x equals negative 2? So, all right, let's just start putting in. This is where we put in values, right? So I'm just going to put in x minus 3. I'm just going to rewrite this inequality. It's greater than negative 2. All right, so they're saying if x is negative 4, that means for x, we put in negative 4 minus 3. That means this answer is negative 7. And is negative 7 greater than negative 2? No, it's not. So, but this is correct. So, all right, let's look at this. So if we put a negative 3 in for x instead of negative 4, the answer is going to be for x minus 3. Well, x minus 3, if it's negative 3 minus 3, you actually get negative 6, right? So let's put that in. If x is negative 2, right? It's negative 2 minus 3. That gives you negative 5. If x is negative 1, it would be negative 1 minus 3. That's actually negative 4. We see a pattern, right? As these numbers go up, because that's what's happening, right? It's getting 1 higher. These numbers are also going up 1 more. So we would predict that this should be negative 3 because 0 minus 3 is negative 3, right? This would be negative 2, negative 1. Well, this has got to be 0 because 3 minus 0, or I'm sorry, 3 minus 3 is 0. And so now we've got our whole chart complete. So here's what we need to figure out, right? Here's what they're asking us. For which values of x is it true that x minus 3, so that's this, when we calculated x minus 3, which ones of these made it true for x is equal to negative 2? Well, we just have to look at our table and right here. When x is 1, x minus 3 is negative 2. So that's actually where it becomes true. So x equals 1 makes it negative 2. Okay. For which values for x is it true that x minus 3 is greater than negative 2? So what they're saying is when we look at this chart, what numbers for x, what in this column over here, makes this answer more than, higher than negative 2? Well, all of these, if this is negative 2, all of these guys are actually negative 3, negative 4. Those are less. So that's less than negative 2. So that's not it. But these here are all bigger or greater than negative 2. So that actually makes it true, right? So what we could write in for this part here is that, and I'm actually going to make it enter sign. So we know it would be x. In order for this to be true, x has to be greater than 1, right? X has to be greater than 1. So when x is 2, 3, 4, those there, I guess, made that true, which I guess technically they're saying which values from the table. It would be x equals 2, x equals 3, and x equals 4. Those all made this particular inequality true. Okay. All right. So now they're saying let's graph the solutions, right? So in order to graph the solutions, we know that, let's see, we'll just make this here. So this is 0, negative 1, negative 2, negative 3, negative 4. So, and let's remember, in order for the answer of x minus 3 to be greater than negative 2, we know that answer had to be more than 1, right? It had to be 1. It had to be bigger than 1. So 2, 3, 4, or anything in between. So we know the answer is really, it had to start here and go here. So anything, as soon as it got larger than 1, it made the answer for this come out to be true, right? Notice I have this open because that means it doesn't include 1. Does not. If it's open, it does not include 1. Because remember, 1 is what made it equal to -2, and this says it can't be equal. It has to be greater than. Okay, so let's look at this one. 2x is less than 6. So this one says predict which values will make it true. All right, so you predict that there. And then it says complete the table. And then did it match your prediction? So go ahead and type in your prediction. And now we're going to start putting these numbers for x into 2x, right? So we're going to see what 2 times x is. I know that 2 times x, if x is -4, then this has to be -8. This would be -6, -4, right? Because 2 times -4, that's all we're doing for all of these. We're literally doing 2 times, because we're putting x in to this expression here, right? So 2 times everything all the way down, all right? We're just typing in the answers there. So this would be -2, 0. Now we're flipping over to positives because these are all positive numbers and we're multiplying by a positive. So 2 times 1 is 2, 4, 6, 8. So, and again, we're looking for less than 6. And you have to decide, did your prediction match? So if I predicted, when I look at this, I would say, oh, it's got to be less. So I predict that all the negative numbers for x will be true. Is that true? All the negative numbers for x. Yes, they were all less than 6, right? When we put a negative in for x in this expression, it does make this side, the 2x, less than 6. Now, interestingly, so we're looking for less than 6. I also noticed there are some positives, though. So did my table match the prediction? Yes, but there were also some negatives, or I'm sorry, positive solutions for x that worked, like 1, 2, and 3, right? Because well, I guess 3 didn't work. Like 1 and 2, right? Because when x was 1 and x was 2, the answers were also less than 6. Okay. Graph the solutions to the inequality. So now this is just saying they want to know, how could we show on a number line to show all the possible answers that would work for x to make this true, right? So we know from here, well, we actually know to make this equal, right? 3. X would be 3. If 2 times 3 makes this 6, so 6 is less than 6. That's not true. But anything less than 3 for x works, doesn't it? Anything more than 3 doesn't work. So we know, and so I'm just going to put 0. I'm going to put in my numbers. So we know if I'm graphing this, it can't be equal to 6. So I'm going to leave a dot open over 3. And we know x has to be less than 3 for this to work. So I'm going to make this go in the less than side, right? So this is showing that. So now we're going to look at this one. Now this I'm noticing is slightly different because there's a negative here. So it says, is negative 4x plus 5 is greater than or equal than 25 true when x is 0? All right, well, let's see here. If x is 0, that means we have negative 4 times 0, which is 0, right? So that would be 0, plus 5, which is 5, equals 25. All right, so, I guess I should read a little more carefully. We're supposed to solve this equation first on the sketch pad. So let's solve it. In order to solve this equation, equals, because we're going to be looking at this, but we have to solve equals 25 first. So when I look at this, I see, I want to get my x's by themselves. So we're going to subtract 5 from both sides, leaving negative 4x on this side, right? Because these cancel. But then I have to subtract 5 from here, which gives me 20, right? So now I have to know, in order for this to be true, negative 4 times negative 5 equals 20, right? And basically what I did there, and I guess I could erase this, is we divided both sides by negative 4. Because negative 4x divided by negative 4 gives us just the x. And that would equal whatever 20, positive 20 divided by negative 4 is negative 5, because we divide the numbers and then we're dividing a positive by a negative, so it's got to be a negative. So x equals negative 5 actually makes this true, okay? So I'm going to write this over here and I'm going to erase because I think we're going to need that room. So we know the answer to the equation is x equals negative 5 to make the equation true. So now it says, is negative 4x plus 5 is greater than 25 true when x is 0? So now we're going to put this in for the inequality, which is a little different from the equation. But all right, so negative 4x plus 5 is greater than or equal to 25. So let's see. If we put a 0 in for x, that makes this 0, because negative 4 times 0 is 0. And 0 plus 5 is just 5, right? So is 5 greater than 25? No. So does this work? No, it does not work with 0. How about when x is positive 7? So now we're going to do the same thing for this inequality, but we're going to use 7 instead of 0. So negative 4 times 7. Well, that's negative 28 plus 5. So negative 28 plus positive 5. I know that the positives canceled negatives. So this ends up being negative 23 is greater than or equal to 25. Does that work? No, not even close, right? So now what if x is negative 20 or negative 7? So if that's true, then that means we're going to have negative 4 times negative 7. Well, a negative times a negative is a positive 28. And 28 plus 5, well, let's see, that would be 33. So is 33 greater than or equal to 25? Yes. Yes, that works. Okay. Graph the solutions to show any single number that could work for this on the number line. Okay. So what we end up knowing, all right, so let me go ahead. I'm going to put 0 here. We know negative 7 works, right? We know 0 didn't work. Anything higher than 0 is not going to work. So for this to actually be true, the numbers have to be, if you put negative 5 in here, that would be negative 4 times negative 5. That's 20. And 20 plus 25. Is 25 greater than or equal to 25? Yes. So you're actually going to be looking at anything that is equal to -5 or less. So the inequality that works is x has to be less than or equal to -5 in order for it to solve this inequality. Okay. So now they're saying, let's find this solution and graph it on the number line. Show your work on the sketch pad. Well, to solve the inequality, what they're basically asking us to do is to find all the solutions that could possibly work. And here's what you can consider doing, right? Back here, when we solved x equals, we made the inequality equal. We made it an equation, and we know for this side to actually be 25, the answer for x has to be -5, right? So we know that that's like a boundary, so to speak. We know that's where this side equals this side, right? So let's go ahead and just solve 3 times x plus 4. We're going to make it an equation first. And we're going to see, what does it take for x to be equal to the other side of 17.4. So just because it's a decimal, don't worry, it works the same way, right? You can use a calculator. So when I look at this, there's different ways to solve it. A lot of you are distributing the 3, which is fine. So you look at this, you can go, oh, well, 3 of x plus 4 is the same thing as 3 x's plus 12. Totally acceptable. If you look at this, then you know, oh, well, we need to get rid of the 12 because we want our x's by themselves. So if we subtract 12 from both sides, we end up with 3x's equaling, okay, I'm not even going to use a calculator for this because I know I can do this pretty easily. 4 minus 0 is 4. 7 minus 2 is 5, and 1 minus 1 is 0. So we know 3x's are equal to 5.4. So if I want to know what 1x is, we just have to divide both sides by 3 because that's what's with our x, right? So I am going to put that in the calculator. So we have 5.4 divided by 3, and we get 1.8. So I know that x equals 1.8. When x in this inequality up here is equal to negative or equal to positive 1.8, I know that this side is equal to 17.4. We need it to be bigger than 17.4, right? So this is where, for graphing this, we have to start thinking, what happens if x, what happens if we pick a number bigger, greater than 1.8? Let's maybe do 2, right? It's a little bit bigger. So if we put a 2 in for this, we would get 3 times 2 plus 4, which is 2 plus 4 is 8, and 8 times 3 is 24. Is 24 bigger than 17.4? Yes. So x equals 2 works, right? Now let's try, just to see where we're going on our number line, what happens if we make this x less than 1.8? So let's do 1. That makes it easy. So 3 times 1 plus 4, right? I just put 1 in for x. So 1 plus 4 is 5. 3 times 5 is 15. Is 15 greater than 17.4? No. Okay. So I know now, if the number of x, if we put in for x anything bigger than this 1.8, like 2, it's going to work. If we put in anything less than 1.8, it's not going to work. And can it equal 1.8? Can x equal 1.8? No, because 17.4, which is what we get when we put in 1.8 here, is not greater than 17.4. So if I'm graphing, then we know, this is a decimal, so we kind of have to know a little bit about decimals, but it's positive, right? So we know 1.8 is almost at 2. So we know it cannot equal 1.8, and I'm going to put a little line coming down here to show that that's 1.8. It can't equal it, so I'm opening it, but it does have to be bigger than 1.8. So anything on this side of 1.8 will work. And so we know x has to be greater than 1.8 for this to be true. Okay. So we're going to do the same thing here. So our steps are going to include basically, I'm going to type these steps out for us. All right. The first step that we're going to do here is solve the inequality like an equation. Okay. Then we're going to plug in numbers bigger than the solution. Plugging in just means we're going to put them in for x, and then we're going to plug in numbers smaller than the solution. And we're going to see if they work. That way we're going to know which way our arrow has to go. So let's try this out. We have to solve this inequality. So go ahead and try to solve this on your own and then see if it matches up. All right, so I've kind of paused. I started writing out this equation to solve it, and I'm using the distributive property, meaning I'm taking the -3 and I'm going to multiply it by both the x and the 4/3. And so I just wanted to show something. So -3 times x is -3x, right? A negative times a positive is a negative. And then we're subtracting, so I put subtract. And then -3, and I want to put this in the calculator to show you. -3 times, and then we have a positive 4/3, right? Because this is subtraction. So times, and I'm going to make this a fraction. So 4/3 actually equals -4. All right. So this is where we end up after we distribute that -3. So we have -3x minus, because we're subtracting, and then the negative times the positive made this a -4 equals 6, right? So now that we have this set up, we're ready to continue solving here. So we want to get our x's by themselves. So if we're subtracting -4, the opposite of subtracting -4 is adding -4. So we're going to add -4 to both sides. And so remember, the whole point of adding the -4 is to get rid of subtracting the -4. So we end up with -3x on this side. And then we're adding a -4. So here we're ending up with 6 positives plus 4 negatives. And so these 4 negatives cancel 4 positives left, and we're left with 2 positives. So x, in order to solve, we're going to have to not subtract. We're going to have to divide, right? We have -3 x's, so we're going to divide this by -3 and this by -3. So x equals -2/3. That's what makes this true, so that 6 is on this side, right? So if x is -2/3, then this whole side is +6. So we're going to use this, right? So we solved it like an equation. We know this. And now what we're going to do, I'm going to go ahead and put my numbers here. So I'm going to do, we have 0. We could put fractions. I'm just going to go ahead and use positive. So this is going to be -1, -2, -3, and so on. This will be +1, 2, 3, and so on. So what I'm going to do now is I'm going to plot negative 2/3 on here, right? Now, I know that this isn't greater than or less than or equal to, so whatever, we could have this answer be negative 2/3. So negative 2/3, okay, we have to think about what that means, right? Negative 2/3 is between 0 and -1. It's almost -1, but not quite. So I'll actually note that this, we're going to say, is negative 2/3. So I'm going to put that down here and just, whoops, I've already put it on the wrong. It's between 0 and -1. So this is negative 2/3, okay? And we already know that the answer can equal to negative 2/3. So I'm going to put a dot here. So we know we're starting with a solid dot because it can actually equal this number. Now, the question is could the solutions be bigger than negative 2/3 or can they be less than negative 2/3 to make this true? All right. So we're going to try one number bigger than the solution and one number smaller. Okay. So let's go ahead and try out. Oh, let's see here. I always like to pick easy numbers, right? Easy numbers. Make them easy. What if we made x, well, 0 is bigger than negative 2/3, isn't it? Let's make x 0. If this is 0, then what's in the parentheses would be 0 minus 4/3. So that's actually going to be negative 4/3, right? And if negative 3 times positive 4/3 is a negative 4, then that means negative 3 times negative 4/3 will give you a positive 4, because a negative times a negative is a positive. Is 4 less than or equal to 6? Yes, it is. So we actually already have our answer, because we know a number bigger, so x equals 0 works, right? So now, just to try it out, let's try an answer or a solution for x that's less than negative 2/3. So on this side, well, let's try, it could be anything. Let's just try -1. Okay. So up here, we're going to put -1 in for x and see what happens. So if x is -1, then we end up having -1 minus 4/3. Minus 4/3. Okay, I'm going to make is negative 7/3. All right. So that means what's in here is negative 7/3. Okay. And now we're going to take that answer, right? Negative 7/3, and multiply it by -3. So I'm going to do that answer times -3, and we get positive 7. So when x is -1, this side is positive 7, right? This whole side. Is 7 less than 6? No, this does not work, which means nothing over here works. If it's bigger than negative 2/3, then that's going to solve our inequality. So our inequality is the solution to this inequality is that x has to be bigger, greater than or equal to negative 2/3. Anything bigger than that does actually work out. Okay? All right. So try this one. We're going to do the same thing. Okay? We're going to solve the inequality just like it's an equation first. Then we're going to check numbers on both sides, right? So here's what I'm going to do. I'm going to copy this text and put it here. We're going to solve the equations like inequality like an equation. Then we're going to use a number bigger than the solution and a number that's smaller than the solution. You try this one out and see how you do. So I just want to pause quickly here to show you when I was solving my equation, which it's all jumbled up right now, but at the end, I had to do 4 2/3, which divided by 4 thirds. And I just wanted to show you that this is what that looks like on the calculator. Okay. And that ends up equaling 3.5. So we know that x is equal to 3.5. What that does is that makes this side equal to 23 thirds. Okay. So again, here's what my work looks like. Um, I subtracted 3 from both sides first, and what I had done is I changed 23 thirds to a mixed number because I knew I could easily subtract from that. So I got 4 2/3 on this side, and then 4 thirds x on this side. And so then I divided both sides by 4 thirds, and that's where I got x is 3.5. So now that I know that, I'm going to start graphing or I'm going to start trying out some numbers here. So I already know, let's see here. So we're going to make this 0, 1, 2, 3, 4, 5, right? So is the inequality true when x is 0? So if I put a 0 in for x up here, um, that means 4 thirds times 0 is 0. So then we get 3. Is 3 less than 23 thirds? Well, yes, because 23 thirds is 7 and 23. 7 and 2 thirds. So 3 is less than 7 and 2 thirds. So does this work? Yes, it does. And so what that's telling us is on our number line up here, whoops, on our number line, whoops, this is -1, -2. We know for sure that x equals 3.5 is kind of like our border, right? So 3.5 is exactly between 3 and 4, right? So we know that x cannot be equal to 3.5 because that would make it that this side is 23 thirds and this side is 23 thirds. And that doesn't work because 23 thirds is not less than that. But in order for this solution to work, we know x equals 0 does work, right? That works. Let's try something larger than 3.5. Let's try 4, right? If we put in 4 up here for x, let's see what happens. Okay. Let's see what happens. So that would mean that we have 4 thirds times 4. Let's try that out on our calculator and see what we get. Okay, so we have 4 thirds times 4. And we get that. And then we're going to add 3, which we get 8.333. And remember that this is 7 and 2 thirds. So does x equals 4 work? No. So what that is telling us is that anything that's going to be less than 3.5 on here is going to work, but the stuff above it, more than 3.5, doesn't. So our actual solution is that x has to be less than 3.5 in order for this to be true up here, to make this side less than this side. Okay. All right, so write at least 3 different inequalities whose solution is this. Okay, so that's a little different. So they're saying we're going backwards. So this makes this a little bit tricky, but that's okay. We know our end result has to be x is greater than -10. So you try those out. There's an endless possibilities here. So you just work on some that you think are true. So I've come up with my own three inequalities whose solution would be x has to be greater than negative 10 for these to work. And all I really did, um, obviously, there are more answers than this, but just some ideas on how I solved these is I kind of started out with just coming up with equations where x equals negative 10, right? So I know negative 5 times negative 10 equals 50, right? And so I that's how I got these numbers first. I just kind of came up with things that where x would have to equal negative 10. Then I went ahead and solved on both sides of this, right? On both sides of negative 10. So here I did, well, what if x equals negative 9, which would be greater than negative 10, right? So if x is negative 9, that means negative 5 times negative 9 is positive 45. Is positive 45 less than 50? Yes. So that means the answer to this has to be that x has to be greater than negative 10, right? And then I just did the same thing with these. I came up with, okay, 2x equals negative 20 because 2 times negative 10 is negative 20, right? And then I just double checked what would make it true so that the answer has to be bigger than negative 10. Well, negative 9 is again bigger or greater than negative 10, so I chose that. I could have just chosen, what if I chose positive 1? That's an easy one to do here. 2 times 1 is 2. Is 2 greater than negative 20? Yes. So that works. So that's just kind of my way for doing this, but that is a challenge. For this one, I want you to just describe how you would solve any inequality. All right. How would you come up with the x is greater than or less than, whatever? How do you solve for them? And then this one is a uh, logic puzzle, right? So you have to figure out which path leads to the treasure, right? So there are many ways you could do this, but one thing you might start doing is if this guy's telling the truth, that means these guys are lying, right? So could this be true? The treasure lies down this path. Okay, that would be true. That would mean that this guy is lying, right? So is he lying that no treasure lies down this path? Well, if he's lying, that means the treasure is down that path, which means that this guy can't be telling the truth. So we already know that this can't be true and that guard 1 is lying. All right. So then let's take a look at this. If that's true, let's see if this guy's true. If he's saying it's true, it says, no treasure lies down this path. Seek elsewhere. That means, well, can it be here? No, because he's lying that it's not down here. And then that would mean that this guy's lying. So the first guard's lying. But if the first guard's lying, that means he's lying, that means he's telling the truth, and we already know that he's lying, which can't be true. So um now we know that he's lying and he's lying, which means he has to be telling the truth. And if this is true, the first guard is lying. If that's true, all right, well, this treasure lies down this path. He's lying, right? I think I made myself confused. This one can't be true. This one has to be true, right? No, I was right. So, all right, this guy's lying, which means this guy's telling the truth, right? That the first guard is lying. And that means this guy's lying, which means that there is a treasure down here. So, where's the treasure? The treasure's with guard 2. And there's your answer. As confusing as it is. So, that was just for fun. And I hope you have a great rest of your day.